Hello everyone and welcome to the architectural concept series. In last video we dig around the ideal architecture and there are few points that we discussed. Out of those 4 points, the first one I chose to discuss it further is the security. So we'll understand the security concept first as per the cloud technology and our responsibility. We did understand the shared responsibility as well. Okay, so we all know the need of security, but what actually are we protecting? In most of the cases, or almost all the cases, it's your data. It's your data that we are protecting, or it's your data where the attackers or the hackers are after. Okay, in almost all the cases, be it's your data stored in a database or it's on the virtual machine disk, we do encrypt the disk, or whether it's a SaaS application or the cloud storage or things like that. So hope you understand what I'm trying to accomplish here. What is happening, all these security measures that we take is ultimately to protect our data. Of course, resources are there, but if anything compromises, it leads to the data ultimately. Okay. Moreover, the data also have some additional legal and regularity requirements. For example, you must have heard of HIPAA, like Health Insurance Portability and Accountability Act in US. You might have heard of the different GDPR in Europe, the General Data Protection Regulation, right? According to GDPR, it should not crosses the boundary of the location and region. Okay, so there are multiple factors also involved, but it doesn't matter if something even not involved, we still need to protect the data, and these factors would even you need to consider before creating your architecture, because you have to follow the compliance and the policies and the government rules and regulations. Okay, so in regards of the security concept, there are multiple layers involved. For example, we did discuss uh, whatever we are creating on the cloud or Azure, the things are happening actual in the data center in that particular region, right? So there is a physical layer involved where the actual data centers, where the all the cooling, power setting and everything is there, some very setup. We are just using the virtualization of the things that cloud provides us, but in reality this is somewhere in the physical location. So security of physical location, or the physical security, or you can say physical layer, because we are learning a multi-layer approach. Okay, let me write this down. It would help us to keep things in mind. How we are doing a multi-layer approach. Let me put it here. Multi-layer approach. Well, as we go ahead, it all started make sense to you. Okay, and you'll start connecting the dots. All right, first one is the physical layer. So we gotta take care of that physical layer. Okay, that involves unauthorized access to facility through methods such as door drafting and theft of security badges, or somebody just jump into the jump into the premises and things like that. Okay, so it's all about physical safeguards against access to the assets. Then we have another layer. You remember the shared responsibility? This would fall for the cloud provider, and then it's our turn where our responsibility comes. So what is the next layer? The next layer is access layer, or we can also call it policy and access layer. I'm creating one more. Okay, cool. Let's make it green, or I chose the wrong one, I think. Yes, cool. Let's make it green, and this is access layer. All right. So what is the access layer in reality? This is where authentication occurs for your applications. For example, when you log into your computer, you type in your username and password, your company's username and password. For example, if you belong to HCL, it's hcl.com, or you belong to IBM. So those kind of credentials. Okay. So Active Directory is involved. So if you remember, we did talk about the exposed credentials, and in Azure AD, they do provide the facility of Active Directory ID protection, where with the help of machine learning and other technology, they help you out to save your identities, right? So that's our second layer, access and identity. So what actually we are doing, I just need to tell you the term for this. This is okay, before I do that, let me go ahead the layers first. If you remember, in access layer, we can also consider the conditional access, ID protection I talked about, the single sign-on or the multi-factor authentication or audit events and those kind of things. Okay, that is the responsibility of you, because now it's you involved, not the cloud provider. Cool. All right. Now the third layer is the perimeter layer. What is the perimeter layer? Well, if you just see your Azure portal, you will find there is something called DDoS on your virtual network. That's your perimeter, Just behind the virtual network is your perimeter. Let's say this, and Azure provides the standard DDoS protection, basic DDoS protection. My apologies, and standard you need to buy. So where the DDoS happens is your perimeter. You got to protect that part. Okay, it's a denial of service. So you got to use perimeter firewalls to identify and alert on malicious attacks against your network. At the network perimeter, it's about protecting from network-based attacks against your resources. Identifying these attacks, eliminating their impact, and alerting on them is important to keep your network secure. Okay, so that's the perimeter layer. So if you're with me, just take it as the way we work on the Azure portal. You see, the physical layer is there, then how people access through the access layer, then what is next? Perimeter layer. Then what would be the next one? That would be network layer. Okay, if you started going deeper, then we'll have network layer, where we put the NSG and all. So unnecessary open ports to the internet are a common method of attack, right? You gotta take care of that part. We do that with the help of NSGs on the NIC or on the subnets, right? Cool. So that's network layer. Okay. So you need to beware of brute attacks here. So you need to take care of your what's that? Your RDP ports, right? Let's make it blue. And in perimeter we had brute, sorry, DDoS, DDoS attacks. It would help you explaining things to the customer or while you're creating your own infrastructure. And here, it's most of the time, I forget to mention ID theft. Okay. All right. So what else can happen on the network? It's all about the communication. You got to limit the communication. You do not allow everybody to talk to only the subnet or the IP which is needed, and deny all. That's how you work for the networking layer. Restrict inbound internet access and limit outbound where appropriate. Okay. And always secure your connectivity to the on-premises networks. Put the network virtual appliance in place if your environment allows that, those kind of things. So you got to protect the network layer. Okay, for perimeter we have DDoS. Okay, we have firewalls. For access layer we have different uh, resources provided by Azure AD. We already talked about that. Physical is cloud providers problem, not ours, but of course it is ours, but their responsibility. So let's go to the so we have come to the virtual network, then to the network layer. Now what it could be? Any guesses? Let's think what it could be. Where we put the NSGs? On the subnet and NIC. So what could be the next? Of course, next is the compute. Okay, compute layer. Or we can say VM layer, but it's fine. So on compute, what kind of threats you can see? The very common and usual is the malware. Okay, the virus, malware, those kind of things. So you gotta put the entire malware, antivirus things in place, right? Or you can implement the endpoint protection, and you can secure the access to the virtual machines. You can uh, give access through your identity source, not so that nobody else can access it. Those kind of things related to the OS. We are not talking about encrypting the disk, because that would fall under which layer? If you can guess, that would be in data layer. So in compute we have malware, antivirus, patching. Don't forget the patching, and the access, secure access to the VM. Now what is there? What is running inside the VM? That would be our next layer. What is running inside the VM? Any guesses? Come on guys, that would be application, right? That's what we run inside the VM. What do we have now? We got application layer. Here we could have what kind of attacks? It's the malicious code injection, SQL injection kind of thing. Okay, so injection attack, we can say, are very common here. Or cross-site scripting is also there. XSS, cross-site scripting. So those kind of attacks are there. So you gotta take care of your applications. You need to ensure applications are secure and free of vulnerabilities. Store the sensitive application secrets in the secure storage medium like Azure Key Vault. Make security a design requirement for all your application development. Everyone should be aware of it. Integrate the security into the application development lifecycle will help reduce the number of vulnerabilities introduced in code. So those kind of things. We do have the other firewall in place that can help your application like WAF. Okay, so the final layer is that we started with is the data. Is the data. Eventually, actually, in all these scenarios, what we are doing everything to protect our data, right? So that's the data inside a VM, inside computer layer, inside application, we have data. Okay, we have data in the database, we have data in the OS disk, data disk, or application backend and the cloud storage. Everywhere there is a data that we are trying to protect. Okay, so that would be the data layer. All right. And it includes exposing the encryption key, or using weak encryption can leave your data vulnerable, or not using encryption at all, or unauthorized access, those kind of things. For example, we use server endpoints or private link instead to go through the internet to access the storage account, or we do encrypt the storage account as well, or the SQL database as well, those kind of things. Okay, so we got these layers, and what do we call it? We call it defense in depth. This is what we call it, defense in depth. In oh sorry. So what actually is happening, we are trying to protect our infrastructure, our data, by providing all kind of security on each layer. Okay, and this kind of defense is called defense in depth. Okay, defense in depth. This is what this kind of approach is called, and this is something very interesting because each layer focuses on a different area where attacks can happen and creates a depth of protection. Okay, that is the reason we go for this kind of security always. It's not only about cloud. You can check anything where the security matters. It is like even in your society, if you see, there would be gates, there would be security guards, then just below that there would be a guard room, there would be inside your tower, there would be another security, there would be a calling system when somebody comes. What is actually happening, there is security in depth. Okay, if you can just relate it. Now there is something I just wanted to introduce for you. This is called CIA, which are the common principles of defense in depth. Okay, common principles of defense in depth are called CIA. Don't worry, it's not that US intelligence. This is something interesting. Once I tell you, you would understand. Well, C stand for confidentiality. I stand for integrity. And A stands for availability. Okay, that's why it is CIA. Now it makes sense, right? I make it a little bigger just to understand. Now let's try to understand these things. These are actually the principles for security defense in depth. Okay, so what is confidentiality? Well, it is the principle of least privilege. Always remember, it's a principle of least privilege. I think I have already talked about it, but if I have not, it is like only give the privilege to somebody which is required. For example, if somebody needs the read access, only give him the read access. Don't provide him anything else. Restrict access to information and provide only or what somebody needs. Only to individuals explicitly granted access. This information includes protection of user passwords, remote access certificates, and email content. Okay, this is where our confidentiality goes. Principle of least privilege. Now, what is wrong with this thing? Okay. Now, integrity. Integrity is prevention of unauthorized changes to information at rest or in transit. Okay, that's why it's integrity. It's unauthorized changes, prevention of unauthorized changes. That is integrity. A common approach used in data transmission is for the sender to create a unique fingerprint to the data using a one-way hashing algorithm. The hash is sent to the receiver along with the data. The data's hash is recalculated and compared to the original by the receiver to ensure the data wasn't lost or modified in transit. Okay, so what the integrity is, it's prevention of unauthorized changes at rest or transit. Prevention of unauthorized changes. This goes for integrity. Okay, cool. Now, availability. Well, this stands for you gotta ensure your services are available to the authorized users. Okay, maybe something happens and you're like your users, your actual people who work for you are not able to access, then it is not a good thing. Okay, so you gotta ensure services are available to the authorized user. For example, DDoS attacks are a cause of loss of availability to users because they give so much of, you know, they send so much of requests to an application, it goes either hung or shut down this server. Okay, it crashes the application. So you got to make sure your authorized users has the access all the time. All right, so this comes under availability. Or I can give one more example, like the natural disaster also drive system design to prevent single point of failure and deploy multiple instances of an application to geo dispersed locations, right? So it is availability, as name suggests, of services. This is the CIA. And defense of depth works on these principles. So you gotta each and every layer you need to understand. Either they belong to C, I, or A, or maybe both. Okay. For example, data. Let's talk about the data. Data encryption at rest in Azure Blob Storage. That would fall under the integrity because unauthorized changes either on rest or the transit. Remember that? Yes. So that would fall under the integrity principle. For example, application layer, where the SSL or the TLS encrypted session happens. Again, the data is moving in transit, so no changes should happen. Unauthorized integrity again. Compute layer. So in compute layer, you gotta make sure your VMs are up and running, whether you're applying the patches or it's a fault domain or update domain or something happens to the VM or the natural disaster. So that would fall under availability. Similarly, network would fall under confidentiality. Principle of least privilege. You would not open the port for everyone. You will just open for one who need it, right? And DDoS we have already talked about for availability, identity and access, as the name says, goes under integrity, and physical is a cloud responsibility, but of course it would go under the confidentiality. All right, so that's all about it. Defense in depth for security. We apply security on each and every layer to make it strong, on each and every layer to protect our data. Well, that's all about it. Thank you for watching. You have a good day.